So defined our predicted value of y. First of all, we need to write our model, multiple model, in the view like this, in expression like this. So first of all, we need to put our a0, then we need to put our a1. This kind of parameters should be multiplied by x1 predicted. So we go to our outputs and we can find that predicted value of x2 is equal 30.01. Then we continue and we put into this kind of place our parameter a2, which should be multiplied by, and we look at this expression, by x2, predicted value of x2. So again, we go to outputs and our predicted value of x2, and this is our x3, or our total cost is equal 41. So we have our basic expression to find predicted value of y, and we just need to do some calculation, very simple calculation by multiply each our regression coefficients by their predicted value of independent variables. Good. So this is our predicted value of y. But we also need to find confidence interval of this value, and to find this confidence interval we use these formulas. So we need to find delta, and for to define delta we need to find first of all t table, or table value of t criteria. You probably remind that for this reason we need to use Skewed-Raspober. We need to put our level of probability, which is equal 0.05. Then our degrees of freedom, it is equal our n minus m minus 1, which is equal 12. Good. So this is our t-table. Then g-residuals. For define g-residuals, we need to use this formula. So again, we put function coding. Then we need to find these differences. This is difference between actual and estimated value. It is this kind of value divided by, again, n minus m minus 1, which is equal to 12. Good. And now we need to find this expression. To find this expression, what we need to find, first of all, it is our matrix of predicted value of x. Again, remind that we have two independent variables into our model. This is our x2 and x3, or x1 and x2, and we need to put this kind of values into this matrix, and the first matrix will equal 1. Why? Like we do the same procedure for identification this outputs matrix of x, and next our predicted value of x2 is equal this value, and this value is equal this value. Good. This is our vector or predicted value of x. And now we need to transpond, to define transpond matrix. A special insert, значение транспонировать. Okay. And then we need to inverse. No, not inverse, but we need to multiply this kind matrix, yes, by using mumnoj, by this kind of matrix which we inversed from the our OLS method, which we use to define our null parameters. So this is our matrix. So we need to use this kind of massive and Ctrl Shift Enter again. And then we need to again multiply the previous matrix by vector of our predicted value of x. So we need to use mumnoj, and we use this kind of values. Ctrl Shift Enter. Good. So next, our step is to define this expression. So we need to use coding from this kind of value plus 1. Good. And now we can define our delta y predicted by multiplication of 3 elements. And now we can define, we need to put our predicted value of y in the middle, and then in this side we need to extract our delta, and in this part we need to add our delta. Good. So we can say that with this probability of 95%, our predicted value of y will be lead between 56 to 86 thousandths UR. Good. So the last our task is to determine the partial elasticity coefficients for the forecast, and you should probably underline that we talk only about forecast or predicted value of y and of our independent variables. So for this reason, we need to use this expression, and the question is how we take the derivative of the expression like this. How we can define the dy dx1 predicted and dy by dx2 predicted from by using this expression. So, for example, partial derivative, the dy by dx1 predicted will be equal what? This kind of our part of this coefficient will be equal a1. So we need to put equal a1, where we can define this a1 from this, for example, or from this place. Then we need to multiply this kind of values by proportion between predicted value of x1, where is predicted value? It is our predicted value of x1, which should be divided by predicted value of y. Good. And the same algorithm we use to define our coefficient of elasticity for x2. So partial, how we can take the derivative of x2. So it will be equal from our again expression from this part, yes. So we look at this expression and we can define that our partial derivative by x2 predicted will equal a2. So we put equal a2, so this is equal this kind of value or on this kind of value, yes, and should be equal on x2 predicted value of x2, which is equal 41, divided by, again, predict value of y, 71. Good. And all these coefficients can show us how our y will change if in first case x1 predicted will change by 1%, if x2 will constant, and in the second case how our predicted value of y will change if our x2 will change by 1%, if x1 will be constant. So this is finish of our laboratory work number 4. That's why I can say goodbye.